This video presents the development carried out by ATOS within the 6GSMART-ICC project with the aim of implementing a public-private network integration system. The solution provides a prototype architecture for the integration of public-private networks from a cloud point of view, based on state-of-the-art research on the design and development of cloud-native orchestration mechanisms in industrial and manufacturing environments, with special emphasis on providing observability and monitoring mechanisms that allow centralized visibility of the managed public-private infrastructure, being able to monitor metrics and KPIs related to the deployed applications and to the infrastructure, abstracting the multi-cluster and multi-domain complexity. The integration of public-private clouds in multi-cluster infrastructures has focused on observability and monitoring through a strategic approach that encompasses both centralized visibility and the ability to react to possible problems that may arise in the managed infrastructure. The solution has been addressed through a unified observability architecture consisting of different components, each responsible for covering specific aspects. Here, we can highlight a centralized observability platform capable of collecting, processing, and visualizing data from multiple clusters, regardless of whether they are in public or private clouds, which allows for a unified view. Lightweight monitoring agents distributed in the different clusters, in charge of collecting metrics and sending them to the centralized platform, allowing that, regardless of the nature of the cluster, whether public or private, it is under the same observability umbrella. In parallel, data normalization mechanisms are available using metrics and log standards, which will allow uniform standards to be established for the metrics, logs, and traces that are collected in each cluster. To this end, a taxonomy has been defined to identify the essential data, latency, CPU memory usage, errors, etc. Finally, it is worth highlighting the multi-cluster monitoring dashboards, which allow the infrastructure to be monitored in real time, providing aggregated and real-time views of the status of all clusters, allowing those responsible for the infrastructure to identify possible errors and detect anomalies quickly. The screen shows how the Infrastructure Resource Service, IRS, based on a defined taxonomy model, is able to collect infrastructure data stored as metrics in Thanos and transform it into a JSON-based data model. The following diagram presents the architecture of the observability stack, consisting of two main components responsible for managing logging and telemetry. We have the Telemetry Collection Center, responsible for storing data and providing interfaces to query and visualize it, and the telemetry agent, which runs on the infrastructure nodes and is responsible for collecting data from the system and applications and transmitting it to the telemetry controller. Cloud Continuum Orchestrator uses OpenTelemetry, a project of the Cloud Native Computing Foundation, CNCF, which defines an industry standard for telemetry data management as the basis for its data collection and processing capabilities. This standardized approach enables the collection, processing, and export of metrics, logs, and traces in a consistent, vendor-independent manner. OpenTelemetry Collector is the central component of the framework and acts as a versatile proxy for receiving, processing, and forwarding telemetry data. The telemetry agent, which is deployed on perimeter nodes and in the cloud as part of the metrics capture process, is configured according to the specific capabilities and characteristics of each node where it is deployed, ensuring optimal data collection. For metrics collection, the agent supports extraction and insertion mechanisms. In extraction mode, the agent retrieves metrics from configured connection points, while in insertion mode, system components actively send metrics to the agent. The telemetry agent supports local metrics storage using Prometheus. For long-term storage, it uses Thanos to store metrics due to its support for Prometheus and advanced features such as unlimited retention and data compaction. Log storage is handled by Loki, selected for its compatibility and ease of use, and Grafana serves as a visualization platform for the collected data. For trace management, the solution of choice is Jaeger, which is an open-source distributed traceability system.
Okay, so now we can go ahead with the demo of the public-private networks integration, where we are going to use the 6G-CAT framework in order to join a new cluster, which is going to represent the public cloud integration. into our constellation and show the updated Grafana dashboard. We can start by seeing the Grafana dashboard that we have running in the hub, where we can see that we are monitoring two clusters, the hub and the recipes, and we have different metric visualizations for the CPU and the RAM. In the diagram, we can see the two clusters. Now we're going to go ahead and join the third cluster, which is going to represent the public cloud integration. We're going to do so by executing the OCM commands. We first execute the cloud init command in the hub, and now we have to copy this join command and execute it in the NUC cluster, which is the public cloud integration. Okay, now we have to go back to the hub in order to accept this join request. We have to wait for the CSR, and now we can accept it. Okay, so now we can see the updated diagram where we have the NUC cluster connected, which, as I've mentioned before, represents the public cloud integration. And now we're going to go ahead and deploy the telemetry agent in the recently joined cluster. This telemetry agent is going to be in charge of collecting the metrics from this cluster and send them to Thanos in the hub. And then from there, we're going to visualize the metrics in the Grafana dashboard. Okay, we wait a bit. Okay, we can see that it was deployed. And now we can see the Grafana dashboard with the updated metrics from the cluster that we just joined. We can see that we have new lines for the host CPU utilization ratio and the RAM consumption. And we can see the nodes where we have the NUC node. Okay, now we're going to make use of the 6G-Quark frontend in order to deploy a service in this new cluster that we joined. We select the manifest and we may manually deploy it in the corresponding clusters. This service is going to be distributed between the RASPs and the NUC. Okay, so we can search and we can see the deployments that were made successfully. Okay, so in this demo, we showed the public cloud integration using the 6G-Quark framework. Thank you for watching.